three different formulas, but really it's just three different variations of the same formula. If you will notice here, if you have the a squared over here, then you have a cosine of a, and then your other letters are your b and c here and bc right here. Okay. If you have b squared here, then your cosine is of b, and then the other two letters a and c go here. And then for the last one, if you have your c squared, your c goes here, and then your other two letters a and b go here. So it's just variations of the same formula. In fact, when I write it on the board, I'm probably only going to write that first one, and you should be able to use that without any trouble. As we get into it, I think you'll see pretty easily what to do. So, law of cosines must be used when you have two sides and the included angle, and I don't know why I didn't put this before, or all three sides. So, two sides and the included angle would look like this. We might have this side right here, we might have this side right here, and we would have the angle that connects those two sides. Okay? That would be, this is not angle side, right? This is side, angle side, right? The angle is between the two sides that you have. It connects those two sides that you have. So if you have side, angle side, then you're going to have to use law of cosines. Also, if you have a triangle where you know all three sides, then you're going to have to use law of cosines there as well. So these are the two cases where you are going to have to use law of cosines for these particular cases. So let's look at a problem. All right, so now I can see here that I've got this side right here is 12. This side right here is 15. I have the angle in between. So if, hopefully I remember that side, angle, side, I need to use law of cosines, I'll immediately know which one to use. But let's say that I've forgotten when it is I'm supposed to use what. All right. Most students tend to lean towards law of sines. They want to use it first because the formula is easier, although not necessarily always easier to solve. But watch what happens if I try to set up law of sines on this. You don't have to write this down. But if I try to set this up, I'd have to use sine 98 over A, because 98 is the only angle I have. But then I've got 12 and I've got 15, but do I have either of the angles across from them? I do not. So it would look like this. I'd have like sine B over 12. And this has two variables. You have an A and a B. Can you solve an equation when you have those two variables? You cannot. So if you try to set up law of sines, it's not going to work. You don't have an angle and the side across from it. To be able to set up law of sines, you have to have at least one pair where you've got the angle and the side across from it. So it may seem a little confusing on which one to choose, but if you try to do law of sines on this, it's not going to work. So if that doesn't work, use law of cosines. Yes, yes. So if the angle is in between, then that is going to have to be law of cosines because you won't have an angle across from any of your sides. So we will have to use law of cosines here. So for this particular formula, I know my angle A, which means over here on the end, I'm going to have that cosine A. So the version of the formula we're going to use for this is our A squared equals B squared plus C squared minus 2BC cosine A. So if we plug in what we know, we do not know A, but we're going to plug in B squared. B would be 12. And then we got C squared. C is 15. minus 2 times B is 12, C is 15, and then we got cosine of 98. Okay. Does it matter which one's B and which one's C? Would it make a difference in the formula if I switched them? It wouldn't, because 12 and 15 here, you got addition between those. You're multiplying here. It's okay to switch your order. So it really doesn't, if you have your A here, the cosine A has to be on the end, but it really doesn't matter what you do with the other two. You can switch them back and forth. Since they are B and C here, I tried to put them in the right spot. Now, here's the good news about this. You can type all of this into your calculator at one time. So either using your handheld calculator, or I'll use Desmos today because most of us are on Desmos because our calculators are missing. If you do use Desmos, be careful because default on Desmos is radians. We want degrees. So make sure you hit the wrench and go to degrees if you're using Desmos. So if you type this in, 12 squared plus 15 squared minus 2 is 12 times 15 cosine 98. Oh, 98. All right, and so I'm getting 419.1023. So A squared is going to equal 419.1023. Keep that in your calculator. Is that our answer? No. Sometimes students put this as their answer. They forget to square root at the end. Think about whether or not it makes sense. You can't have a triangle where one side is 12, one side is 15, and the other is 419. That would not work, right? So make sure your answer makes sense. It'll help you catch some of your small mistakes. So we'll do square root of, we'll copy and paste this. So we get 20.472. If we square root both sides, so 20.472 would be our answer for side A. Now, the formula looks more complicated for law of cosines, but I think they're easier to solve. Because for law of cosines, you will never have an ambiguous case for law of cosines. Law of cosines always has one single answer because you're either starting from side angle side, which defines one single triangle, or from all three sides, which also defines just one single triangle. You're not going to have an angle side side situation for this. So you should always get just one single answer, which makes these a little bit easier. Plus, this is like simple to type into the calculator here as well. So the formula looks more complicated. Most students do better with law of cosines, though. Even though they're usually okay with law of sine as long as I don't throw an ambiguous case at them. All right, we okay here? Yeah, those ambiguous case problems, they'll get you. One or two, probably. But it's not going to tell you which ones are ambiguous case. So, you have to watch out. Alright. Car A and car B leave the same point at the same time. Car A travels north on a straight road at 60 miles per hour. B travels 20 degrees south of east on a straight road at 45 miles per hour. After 2 hours, how far apart are the cars? I think this stuff is sort of cool. You know, if you're thinking of like, you know, being in the police helicopter, car A is like, you know, leaving the crime scene, headed one way. You know, on the ground, the police might think it's a different car and go the wrong way. But then when the helicopter gets up there, you can like spot it. You can figure out how far they are away. You know, you can kind of see. Now we're simplifying it a lot, so you can kind of see where this could like come into play here. So if we have car A, we have the crime scene right here. We're going to put it at 0, 0 because that'll be the easiest place for us to start from. Car A travels north on a straight road at 60 miles per hour. So car A, we'll say this is our criminal, the bank robber with all the money, has gone north for 2 hours. Okay? Car B travels 20 degrees south of east. So we need to know our directions. North, south, west is over here, east is over here. And we're going south of 20 degrees south of east. So south of east. East is the main direction. You're going 20 degrees to the south of that. It would look like this. And that angle right there would be 20 degrees. Okay? So this is going to be car B. So our criminal is all the way up here. Car B, the police thought they were chasing somebody, but it was actually not the right criminal here. They did this for 2 hours, so they're way off now. Way off. So we need to figure out how far they went because they didn't tell us the distance, but we should be able to figure it out pretty easily. So this is 2 hours have gone by. The car A was going 60 miles per hour north for 2 hours. How far did car A get? 120. And then how far did car B get? 90. All right, so let's say they finally, catch car B right here, who has led them on a slow speed chase for 2 hours. So they realize B is not who they're actually looking for. And then they get a tip that it was actually this car over here. And so let's say the police helicopter is over here. It wants to go straight to this other car, right? Because that's actually who they're looking for. So we want to know how far it is from one to the other. Okay, so in this case, I have this triangle. It is not a right triangle, so I'm going to have to use either law of sines or cosines. Do I know any of the angles of this triangle?
Yeah. You can figure out that the 20, there's a 90-degree angle there, so you can figure out the one below it.
Okay, so 20 is not actually an angle of my triangle, but I can figure out this angle right here. What's it going to be, Luke? 110. Because we could take that 90-degree angle and add the 20 to it. So now I've got this triangle that I'm looking at here. Let's highlight it. We're looking at this triangle. I have two sides. I've got the angle in between those two sides. So this is going to be a law of cosines problem. All right. So the side that I'm looking for is the side across from the angle. That's my x squared. Is going to equal, it doesn't matter which one, 90 or 120. It doesn't matter which one is B and which one is C here. So I'm going to say 90 squared plus 120 squared minus 2 times 90 times 120 cosine of 110. All right, so we're going to type that into our calculator. 90 squared plus 120 squared minus 2 times 90 times 120 cosine 110. And so we get 29,877. Is that my answer? Square root that. And so when we square root this number right here, we will get 172.880. So if we got the helicopter going, I'm thinking they can make it there in half an hour. But now here's, I get questions a lot about what is calculus. So let me show you something. This is a pre-calculus problem. Obviously you are in pre-calculus, so that makes sense. But when I say pre-calculus, it also can mean like anything before you know how to do calculus, right? So you learn this before, has no calculus in it. And so what you have found is the distance from B to A, assuming A and B are sitting still, right? So if this is real life and A is on the run here, so this is like A has stopped at a gas station to take a break from his chase for a while, right? And so the helicopter is going to be able to fly from B to A. But if A is not stopped, if A is continuing to go 60 miles an hour north on that straight road, right, then this becomes a calculus problem. Because what's going to happen is that distance right here, this 120, is increasing. So as the helicopter is trying to go to where they're going to... Yeah. So as the helicopter tries to fly to this area, if you were to know this, you could figure out like exactly what direction the helicopter needs to fly in to intercept the A on down the road instead of like flying to A and then having to fly across. So you could turn this into a calculus problem if A was still moving, right? Because it would be changing. So that's kind of like the idea of a lot of things in calculus is instead of things being sitting still, like here is this triangle, we are trying to find this missing side. It is like, here's this triangle, this side is getting bigger at this rate. How can you find, this value for this time in the future? So it's, it complicates things because you have things that are changing versus just static, just sitting there. So that's like an idea of some stuff that we would do. In fact, I think we do a problem similar to this when we do related rates in calculus here with A still moving here. So it's kind of cool. I like it. But we, of course, won't do that in here. So this is our answer. Okay, questions? All right, we're going to do one more here. And so for this one, we just have 3 sides. And they ask us to solve the triangle. Okay, so if you have 3 sides, you have to use law of cosines because you don't have an angle. And if you don't have an angle, you can't use law of sines because it requires at least one angle. So we've got x, y, z. So if I label this, the shortest side is 14. That's x. The next longest is, that should say y equals 19. That is a typo. And then z is 22 here. So if you get a problem like this, it may ask you for a specific angle or it may ask you to solve the triangle. This one has asked us to solve the triangle. So we can find whichever angle we want to find first. So Leah, which angle do you want to find? X, Y, or Z? Okay, so we found Y first. Then that means I need to use 19 squared equals, and then 14 and 22 are my other 2 sides. So I'll have 14 squared plus 22 squared minus 2 times 14 times 22 cosine of y. So it's important here because we're looking for y. We have to have this side over here has to be the side across from y. So we got y right here. Side across from it is 19. 14 and 22, it doesn't matter which one you put in which place here. Now, this is a little more difficult to solve than the other problems because you're going to actually sort of have to solve this as an equation. So if we do 19 squared, we are going to get 361 equals, and then 14 squared. I I can do 14 squared plus 22 squared at the same time. That's going to be 680. I was doing all of this stuff together. And then 2 times 14 times 22 is going to give me 616 cosine y. Nope. Yes. Yeah, that's what we're going to do. So, can we put 680 and 616 together? This has a cosine y with it. It's multiplied by cosine y. It's like trying to put a 680 and a 616x together. They're not like terms. So, you may want to put those together, but you cannot. So, we have to do what Luke was saying. We're going to subtract that 680. So, we'll get 361 minus 680 is going to give us negative 319 equals negative 616 cosine y. We'll divide by negative 616. And I'm getting 0.517857. Keep that in your calculator. And then what do I do to get rid of cosine? Inverse cosine. So cosine inverse over here, we'll get rid of that cosine. And if I do inverse cosine of that answer I just got, I'm going to get 58.811 degrees for my y. So 58.811 degrees there. Inverse on Desmos, if you go to the keypad and go to functions, it's there. You should have inverse trig functions there. Yeah, so I need to do this again. Now, you have options now, though, because you could just use law of cosines again, right? We could set up the same thing but find x or z. So if you like law of cosines and like doing what we just did, you can. But now that we have an angle, I could also use law of sines, right? So if I wanted to for this next part, I could do sine of 58.811, that angle I just found, over 19. And it'd be even better if you stored that. But I realize we don't all have calculators. You can copy and paste in Desmos. Would equal, you can find x or z, it doesn't matter. I think I'll do x. So sine x over 14. And you will cross multiply. So you'll get 19 sine x equals 14 sine 58. Gracious me. 58.811 degrees. We would divide by 19. So if we type that in, 14 sine of that number divided by 19 is going to give us 0.6303. And then to get rid of sine, we do sine inverse. And sine inverse of that answer is going to be 39.076 degrees. Again, you could use law of cosines if you'd rather. There, it's fine. So we get these two angles. Now that you have two angles, to find the third one, you're going to do 180 minus 58. .811 minus 39.076. So we'll get 82.113 degrees for Z. So we would have these three pieces for our answer. I will warn you, if you do law of sines, right here, there is a chance for ambiguous case here to happen, but it usually can be caught by checking to make sure, like here, when I get 39 degrees, that looks, well, I didn't draw to scale, did I? But 39, this is your smallest angle, right? So if you do 180, I'm not even sure if it is ambiguous case. If you do 180 minus 39.076. Yeah, it doesn't work anyway. This one's not ambiguous case. But, like, sometimes there is a chance for ambiguous case. But if you look at your picture, if you've drawn your picture anywhere close to scale, you should be able to tell whether it's, like, obtuse or acute. So this is an acute angle, so you would want to go with the 39, not the 140-something there. So it's rare that you run into one where that ambiguous case pops up. From that, it's usually going to be the first answer that you get. But check with your picture if it looks way off from your picture. If, like, you can tell it's an obtuse angle, but it looks like if it's saying it's 20 degrees, then that could be the case. But it's pretty rare for that to pop up.
So if we use law of cosines, is that?
Yeah, if you have law of cosines, it should not happen. So you can avoid that altogether by doing law of cosines. It is really rare with the law of sines, so you're not running a huge risk by doing law of sines instead if you prefer it, because it typically does not happen. And if you check with your picture, it should be fine. Pictures are not drawn to scale, but they're usually drawn to scale, right, or pretty close, right? So if it looks obtuse and you're finding out the angle's only 20 degrees, that should be an alarm to you. Okay, questions? All right, so